Hello, 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 everybody. Welcome, welcome, welcome to office hours for World Quant University Unit 2 ML. How is everybody doing this morning? I see a lot of familiar faces in the chat. I see Rahik is here, Innocent is here, Arthur is here, Amar is back. Ariel, good to see you. And Tina is also here. Welcome, Tina. So good to see everyone. And Stefan is also here. Great. Ariel says they have a question. Hit me, Ariel. Tell me what it is. And Sahin is also here. Welcome. Is everyone excited for some data science? I see Chuka is here. Welcome. Mauro has also joined us. Welcome, welcome. It seems like everyone's here. And Thomas is here. Welcome, Thomas. All right, let's get started. I know we're going to work today on the ML mini project, and so we'll definitely look at that. And I remember yesterday, people were interested in seeing the difference between precision and recall. Oops. Okay, good. And Arthur obviously wants to see question 3. We'll definitely have time for question 3. Ododo is here. Welcome. And Ariel has a question about Netflix. And Ariel's asking me a question about the global marketplace in streaming entertainment. Let me see if I can summarize this question. So Ariel is saying that next month Disney is going to join the market with their Disney Plus service. And both Disney and Netflix is currently the video streaming leader, he says. And both companies, Disney and Netflix, are using data science to drive success in the entertainment industry. And from my perspective, one, what would a data scientist recommend Netflix to maintain its status? And two, what would a data science recommend Disney do to catch up better or better beat Netflix? Well, I think the truth is that I really have no idea because while I am a data scientist, I do not know a lot about entertainment or even though I live in LA, but I don't know anything about entertainment, and I don't know a lot about this marketplace, like global streaming entertainment marketplace. And I suppose the question is, or what we need to think about is, what is the metric for success for Disney and Netflix? What is it that will make them successful in the marketplace? And I know that answer is going to be number of subscribers because in the old TV system, before we did streaming, so I'm thinking back when I was watching TV like in the 80s and 90s and early 2000s, it was all about it was all about um, uh, viewership, right? How many people were watching? And I already see people putting in their ideas. Let me hear your ideas. What would you guys recommend Netflix do or Disney do? And so the question is, I would say let's come up with a bunch of experiments to see what it is that best increases, or rather increases subscribers, but also maintains current subscribers. So what we would want is we would want some sort of model that would predict churn. That is to say, how many people are leaving the subscriber base. And then we would think about ways in which we can reduce that. So I might do a lot of sort of random sampling of viewers and trying to see what works and doesn't work, either looking at historical data to maybe get an idea, and then going into experiments to seeing how I could affect or shape user behavior, whether there are certain um, shows that have some sort of global appeal. But at any rate, the idea is that you need to increase subscribers and reduce churn. And however you can do that is, well, it's with content. And the question is, what is the content you need to drive those subscribers? So I don't know. We'll find out. Okay, I see some other people have, and Innocent makes a really good point. This is why data scientists need to work with domain experts. So you can't just build a model in a vacuum. You need a domain expert to kind of help shape your modeling efforts. Okay, so we have Sandra is here, Murat is also here, and I want to talk about precision and recall. Thomas is saying on precision and recall, is it possible to determine the same for more than two classes? Absolutely, but for now, I'm just going to do a quick rundown of what precision and recall are. So what I'm going to do is I'm going to draw 10 faces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I understand that these aren't very good faces, but let's just say each of these represents one person. And let's say that I am a judge. And I need to decide whether each of these people, let's call them defendants in a trial, is guilty or innocent based on the evidence. Now, the people that are truly innocent, that is to say they committed no crime, I'm going to color them as green. And the people who are truly guilty, that is to say they know the truth, I don't know the actual truth, I just know the evidence, these people are guilty. So green is innocent and red is guilty. Now let's say I, as a judge, am using a machine learning algorithm. I'm using a machine learning algorithm which will decide whether these people are guilty or innocent. And let's say that I just create a simple algorithm, and what it is I will say that everyone is innocent. I will just decide that they're innocent automatically. So these green arrows will represent me declaring them innocent. All right, so my algorithm here is everyone's innocent. All right, so how can I judge whether my algorithm is a good algorithm? What are some metrics I can use to judge whether my model is working or not? So Shaban says maybe I could use accuracy. So the accuracy of my model is 60%. The accuracy of my model is 60% because I said everyone was innocent, and in fact, 6 out of 10 were innocent. So is that a good model? So Tom Dang Min says no. Gavin says it might be. Innocent says no. What if I change this a little bit? What if instead of, let's say that in fact, 8 out of the 10 people are truly innocent. And my algorithm, which is everyone is innocent, now the accuracy is not 60%, it's 80%. Is this a good model? What do you guys think? Abu says yes. Florin says no. Lady says yes. Yeah. Everyone says yes. Ariel says no. Why, the people that are saying yes, why are you saying yes? And the people who are saying no, why do you say no? Now, Florin says it has just high accuracy. What does it mean, Florin, when you say that it has just high accuracy? Now, Stefan has a really interesting point. He says, we do not need to compare with real data. Let's think about it this way. Let's change the scenario again. Let's say that this is not people who are guilty or innocent, but let's say that this is people who I'm giving brain scans to see whether they have a brain tumor or not. They have a brain tumor or not, and my metric is, I'll just say everyone, green is they don't have a brain tumor, and red is they have a brain tumor. And my model is tell everyone that they don't have a brain tumor. And now my accuracy is not just 80%, but it's actually 90%. Now I have 90% accuracy. So now I have 90% accuracy, guys. All I need to do was say everyone is clear, everyone is healthy, and I have 90% accuracy. Is that good or bad? Ariel says it's bad. Why is it bad? And Yasser has a really interesting point. They say we have more cases of people that don't have a tumor than do have a tumor. So I have, if 9 out of 10 people are healthy and one is unhealthy, and I just say everyone is healthy in my model, it's not a very good model because it's just, while the accuracy is 90%, I'm not actually adding any new information to this picture. If I know that 10% of people that have brain scans have a tumor, well, then my model doesn't improve on that baseline. And the other thing, and Oreva is making this really good point, which is this one person who who has a brain tumor, but I say they don't have a brain tumor, that's a very high cost for me getting wrong because they'll die. Like Ariel says, I'm murdering someone. It's negligent. It's medically negligent for me. And so, what we're finding out through this discussion is that accuracy is not always the best metric to judge whether your model, your classification model, is good or bad. And so, if accuracy is not always the best metric to use, the question is, what metric do you use? And I see people throwing around terms like false negative and false positive. Let's not worry about those yet, but we'll get there in a second. So let's go back to my courtroom scenario where I'm a judge and I have to decide whether people are guilty or innocent, and the people that are green are innocent and the people that are red are guilty. And let's say that these are the judgments that I make. I say that person 1 is innocent, person 2 is innocent, person 3 is innocent, person 4 is innocent. I actually think that person 5 is guilty, person 6 is guilty, but I also think that person 7 is innocent, person 8 is innocent, and then persons 9 and 10 are guilty. So these are on top. The circles is whether, in fact, they committed the crime or not. And down below, the check marks are whether or not I find them guilty or innocent. And on the ones that I get right, that is to say, they did not commit the crime and I find them not guilty, those are true negatives. And the ones who actually committed the crime and I think they did, those are true positives. And in the middle, we have the ones where I get things wrong. The ones where they are actually innocent, but I found them guilty, I convicted them. That is a false positive. And the ones who actually committed the crime, but I found them innocent, that is a false negative. And so now that I have this information, I can calculate precision and recall. Whoops, sorry everyone. I know you can't see the thing here. Sorry about that. And so in order to calculate the precision, I'm going to take the number of true positives and I will divide it by the number of true positives plus the number of false negatives, which is the same as 2 over 2 plus 2. So my precision is 0.5. And my recall is true positive over true positive plus my false, no wait, I always get this confused. This is false, hold on, I'm confused here. This is, I always get these formulas wrong. This is false positive. Precision is false positive. There we go. And this is false negative. In this case, it doesn't actually make any difference in terms of the calculation. So I have 2 over 2 plus 2 equals 0.5. Now, those are the mathematical formulas, but what does that actually mean in terms of how can we say that in human language, not in math? So precision is how good I was at identifying people who were truly guilty, how good I was at convicting people who were guilty. And recall is how successful was I in catching, convicting all of the guilty people. Now, let's take this one step further. I'm going to delete all of this. And what would I do if I wanted to increase my, let's think about it this way. I'm going to delete this as well. And I'm going to delete this as well. Okay. Now let's say that instead of just guilty or innocent, I'm going to give some sort of, instead of doing predict, let's say I'm doing predict probability. And what I don't have, I'm not going to give a guilty or an innocent or guilty verdict. I'm going to give you a percentage which will quantify how certain I am that the person is guilty. So for example, person 1, I'm going to give them a 0.05. So I'm 5% certain that they are guilty. Person 2 is 15%. Person 3 is 30%. Person 4 is 51%. Person 5 is 0.6. and person 7 is 0.2, and person, where are we at? 7 is going to be 0.7, and person 8 will be 5.8. Person 8 will be 9%, and person 10 will be 99%. So now I'm not saying whether they're guilty or innocent. I'm quantifying how certain I am that they are guilty or innocent. And so the question that I have for you guys is, at what point should I set my cutoff? At what percentage certainty should I be before I actually say that I declare them guilty? Florence says 55%. Ariel says 40. So if I'm 40% certain that somebody is guilty, I'll make sure they're guilty. I'll declare them guilty. And Abu Keita says above 50%. Or Ampofo says 51%. Okay, same thing. So it does make some sort of logical sense that if I think that somebody is above 50%, well, then they're, in my mind, more guilty than not, so I should declare them guilty. But Christian raises a really good point. What if this is a death penalty case? If this is a death penalty case and the person who I declare guilty will die, the people that I declare, let's say I do my 50% cutoff, I'll do my 50% cutoff, and if I do my 50% cutoff, all of a sudden, I'm going to be sending two people to death, even though they're innocent. This is not good, right? We don't want to send innocent people to death row. On the other hand, let's say that I change my threshold from 50% to 90%, like Christian is suggesting. So all of a sudden, these people who are actually innocent, I will find them to be innocent. But at the same time, two people that are guilty will not be given the death penalty. They'll be let go even though they committed the crime. So, which is better in the case of a death penalty case? Is it better to sentence innocent people to death, or is it better to let guilty people go free? Because I can't have it both ways. And Florence says we don't execute innocent people, right? It's better to kill less people than more. And that's why Christian says, and so a lot of people are saying this, right? If you have to make an error it's better to err on the side of letting guilty people go free because the ramifications, the effect of sending innocent people to death is terrible. And this is where we get to the trade-off between precision and recall. If my model is more concerned about recall, that is to say, making sure that I get all of the guilty people, I'm going to lower my threshold. I'm going to lower my threshold even though I know that in lowering my threshold, I am more likely to send innocent people to death. In fact, if I went full only recall, I could just declare everyone guilty. I could lower my level of my cutoff to zero point zero 0.01. If it's more than 0.01, you're guilty. So that's high recall. And the problem about high recall is that you get a lot of these false positives. These false positives. On the other hand, if I were to favor precision in my model, that is to say, correctly identifying those who are guilty, I would run into the problem of false negatives. That is to say, in making sure I only convict the people that I'm really, really certain about, there are going to be some guilty people who I will let go free. And so recall, again, is about grabbing all of the guilty people, even though I send innocent people to jail. And precision is about correctly identifying the guilty people, even though there may be some cases where I let guilty people go free. And whenever you're doing some sort of classification problem, there is a balance that you need to strike between precision and recall. Because Christian is asking, can you have both? You can't have both, right? Models aren't perfect. Now, in terms of us being ethical people and citizens of the world, we want to strive for a world where this doesn't happen. But when we're building a model, like as a data scientist, you have to find the trade-off between precision and recall. And in some models, precision is more important, and in other models, recall is more important. And Rishab is asking what is generally preferred, and it's very context dependent. Let's think about it another way. Let's say that these are not people, but they're emails. And what I want to do is I want to create a spam email detector. And so if someone sends me a spam email, I will delete it and the user will never see it. So which is more important? Which is more important in a spam detector model? Is recall important? That is to say, getting all of the spam messages, even though you might delete some important messages? Or is precision more important? only deleting the emails that you are certain are spam, even though that means that the user is going to see a few spam emails. Which is better for a spam detector? I see some people saying precision is better, and I agree because you definitely don't want people to lose their emails. Let's do another example. Let's say on my phone, so here on my phone, I have an app, and what the app does is when somebody calls me from a number that is like a number where they're trying to sell me something, it doesn't pick up. It just sends them to voicemail. So if it classifies it as a marketing call, it goes to voicemail. And if it doesn't, it lets it ring, and then I can pick up. Now, if somebody who calls me and they are marked as spam, what happens is they leave me a voicemail, and then I check my voicemail, and I'll see that it's a person and not a telemarketer. So which is better in that case? Is it better to favor precision or recall? Here, the answers are a little bit more mixed because the stakes for the problems caused by incorrectly a false positive, having somebody call and go to voicemail is not as bad because they just leave a voicemail and then I see that they called. Whereas letting someone, a telemarketer, call me and interrupt my day while I'm teaching my students, that's worse. So maybe in that second example, recall is a little bit more important than precision. And so Innocent raises a really good question. They say, does the spam example or the telemarketer example seem as though it depends on what's at stake? And that's absolutely right. Precision and in recall is exactly about what's at stake. And Pallavi makes a really good point. What if it's an urgent call? What do we do then? So again, these are questions that we as data scientists need to figure out when we're deciding what our threshold is going to be. So again, recall is about getting all the guilty people, even though you convict a few innocent people or convict a lot of innocent people. And precision is about making sure you are absolutely 100% sure that you're convicting guilty people, even though there are a few guilty people that will go free. So, any questions about precision and recall now that we've talked about them? Christian says no. So, Yasser wants to know, where is accuracy important? And accuracy is important always, but it's not important in isolation. You need to put the accuracy metric into context. So that means either including other things besides accuracy, like precision and recall, with the metrics you're using to evaluate your model. And also, it's helpful to put it into context with some sort of baseline, right? Here, I can see that in my population, I know that in my population, I know that 60% of the people are innocent. And so if my model accuracy is 60%, like that's nothing new. It does no better than what we call a naive classifier. That is to say, a classifier that just predicts the majority class. So accuracy is important, but you need to put it into context. And Rishab is asking, generally, what is the ratio between between precision and recall? And there's no hard and fast answer here. It is very context dependent. Now, one thing to keep in mind, if I have a model, and what I do is I'm going to evaluate it by looking at, let's say I plot recall on, well, actually, let me do it this way. So let's say that I'm going to do two different plots. So let's say that red is precision and green is recall. And this is generally what you see as you change that threshold, that guilty innocent threshold. Precision goes down as recall goes up. So that's one way to look at what is the ratio. You might want to, you'll need to kind of decide whether you want to favor precision or recall, or whether you want something here that's like right where they meet. The other thing that you can do is I can plot, let's say I plot recall on the x-axis and precision on the y-axis. And so this is 1, this is 1, and then down here is 0. So the best recall or the best precision is 1. Well, let's say that I have two models that I'm evaluating. Let's say I have the orange model, and what I can see is that the precision recall curve looks like this, where as recall gets better, precision gets worse, or I have this blue model, which looks like this. Which of these model is better? Which of these models do you think is a better model? The orange model or the blue model? Ariel says blue. I see one person saying orange and blue. Why? Why do you think blue is better, or why do you think orange is better? It looks like people tend to like blue better, but I see a few oranges. Why, the people that say orange, why do you say orange is better? The people who say blue, why do you say blue is better? Ariel is saying it's the ideal. What does that mean, it's the ideal? Florin says it's better because the precision doesn't go down. So what that means is that as recall increases, precision doesn't go down as much. So usually we see there's a trade-off between precision and recall where they cross like this. That's not happening in this case. With the orange model, there's more of a trade-off, where as recall gets better, precision gets worse. But like Innocent says, and as Abu Keita has also said, the blue line is almost an ideal. That is to say, the best that you could do, and I'll do this in pink, the best you could absolutely do would be to have a line that is straight, horizontal, which means there's no trade-off between precision and recall. So another way to, so often what you're looking for is you're looking for a model. You might think, what do we need, precision or recall? We can't always get both. Orange is, and so what I can do is whether I have an orange model like this one, whether I have a blue model like this one, or whether I have the ideal pink model like this one, what I can do is I can measure this precision recall trade-off, and I see that Ariel has already put this in the chat. I can measure the area underneath these curves. So I can measure this area versus this whole area. And the best that I can get would be the pink, which would be something like 1, whoops, sorry. The pink, which would be like 1.0, and the blue would be something like, 0.80, and maybe recall, the orange one would be something like 0.72. And so here I'm looking at what's called the AUC, or area under curve, which helps me evaluate the precision recall trade-off. And there's always a trade-off between precision and recall, but what we strive for in our models is to make sure that it is as small a trade-off as possible. And so what we want to do is increase the area under the curve. So to summarize our discussion of precision and recall, recall is about getting all of your positive class, right? It's about getting all of the innocent people, even though, excuse me, it's about getting all of the guilty people, even though you might wrongfully convict some innocent people. Precision is about making sure that you are very certain in identifying the guilty people, even though it means that you have some guilty people that get away. And there's always some trade-off between precision and recall. And one of the ways to visualize that trade-off is to look at the area under the curve to see whether there is a trade-off or not. And the ideal, just like the ideal precision and the ideal recall are at 1, the ideal area under the curve is also at 1. But Again, that doesn't often happen. So you as a modeler are trying to decide which is more important, precision or recall, depending on the case, and then also trying to increase that area under the curve and try to push it towards 1. Okay, questions about precision and recall. So Florin has a question. They want to know, how do you get a 0 at recall when you have perfect precision? Let me think about this. Well, I suppose if you had perfect precision, I have to think about this. I'll have to get back to you. It's a mystery. But if you perfect precision, here's the answer. Precision is about correct guesses. So if I have 10 people, if I have 10 people and I'm only going to declare guilty these 2 because I'm very, very certain, I will have high precision because there's nobody here that I incorrectly called guilty. However, my recall, if I'm measuring recall, I missed these people here, or excuse me, these 2 people here. So I can have very good precision. That is to say, every time I make a guess, it's correct. But, or every time I make a designation, I'm correct, but I'm still missing some. And Florin's right. Maybe we need to call Sherlock Holmes. They can always help. Now, Pallavi says 0 recall and n precision. Can we call it an ideal condition? I wouldn't say it's an ideal condition. The ideal condition would be to get 1 recall and 1 for your precision score. That would be perfect. What other questions can I answer about recall and precision? It's a complicated, it's a hard concept to wrap your mind around. So I'm glad we're spending time on it today. So Rishab wants to know 1 for recall and 1 precision. How is it possible? Well, let's look at how it could be possible. Let's say that I am changing my, let's change the percentages here. And let's say that anyone over 0.89, I'll convict. And so based on that new threshold, these will be my judgments. And I like the way Yasser is saying it. I often think of it as this way too. You can kind of think of it as precision. It's actually Yes, precision is important in a democracy and recall is important in a dictatorship. That's a good way to think of it, I think. Now, going back to Rishabh's question, here is my verdicts. Here are my verdicts based on these probabilities. What is my precision and recall here? Well, let's calculate them. So my precision is going to be true positives over true positives and false positives. So here I have 4 true positives divided by 4 plus, and there are no false positives. So I have 4 true positives and no false positives. So I have 4 over 4, which equals 1. And then I have recall, which is going to be true positives over true positives plus false negatives. So I'll have 4 over 4 plus, there are no false negatives, I have a 0. So again, I have 1. So the way to get precision and recall to be both at 1 is to get everything correct. So Rishabh, does that answer your question? And Rashab is making a good point. In this example, the threshold could even be lower, and I would still get good precision and recall in this case. That's true. That's true. But you as a data scientist are going to need to play a little bit with these probabilities and play a little bit with precision and recall based on the needs of your client or your client or your, and Rashad makes a really good point. The data is generally very scattered and all over the graph, right? It's rarely as transparent as what we see here. It's rarely that easy, which is why there's always a trade-off between precision and recall. And that's why you as a data scientist often need to figure out which is more important to your client or to your stakeholder, precision or recall, and tune your model accordingly or decide what your metrics are accordingly. And Pallavi makes a good point, right? In this small data set of 10, maybe 60% works as a threshold, but if we had more and it wasn't always as certain, well, then maybe it wouldn't work. And that's why it's important to have your training set and your testing set. Okay. Well, it looks like we spent all of today on precision and recall. I'm sorry we didn't get a chance to go to the mini project, but I do think it's good that we spend all this time talking about precision and recall because we had like a really in-depth discussion and it's a complex topic, so I'm glad we got to look at all the finer points of it. I hope that I hope that you have also found it helpful because I know that I did. So I will see everyone tomorrow. Then we'll move on to question 3 of the mini project. And until then, I hope your data is clean. I hope your models train quickly. And always remember, happy, happy machine learning, and I will see you all tomorrow. Take care.